my name is Nurul Syazwani binti Skelan, DE 200083. So, I will present about question 1 and question 2. For question 1, for one Roman, A dx over dt equal 3t power of 2 minus x power of 2 over t minus 2x. We should multiple to 1 over t because to terminate the t. So we get new dx over dt, which is equal 3t power of 2 minus x power of 2 over t power of 2 minus 2xt. So firstly, we should make sure that the differential equation is a homogeneous or not. So we get the equation is homogeneous equation with degree lambda equal to. So next step is substitute x equal tv and dx over dt equal to t dv over dt plus v. So next is t dv over dt plus v equal 3t power of 2 minus t v power of 2 over t power of 2 minus 2 tvt. So next step is we should solve the equation by the method of separation of variable. Okay, and we get the answer is negative ln 3 plus v power of 2 minus v equal to ln t plus c. C is a constant. So we should substitute back v equal to x over t. So we got negative ln modulus 3 plus x over t in bracket 2 minus xt equal ln t plus c. For next question is dy over dx equal 1 minus 2y minus x over 4y plus 2x. So the same method, homogeneous. So make sure that the differential equation is a homogeneous or not. For the equation is this is defined of dy over dx equal to ax plus by plus a over n in bracket ax plus by plus b. So for this we should use transformation v equal ax plus by. So we know that a equal minus 1, b equal minus 2. So for the transformation is v equal negative x minus 2y. So we should differentiate of dv over dx. So we get negative 1 minus 2 dy over dx. So we want dy over dx. So we get dv over dx plus 1 over negative 2. So we do the method of separation and we negative x negative 2y over 2 equal x plus c. C is constant. So this is the simulation. We use MATLAB. This is for simulation for question 1 A1 and this is simulation for question 1A2. So next is so that the solution yx dy over dx equal to y power of 2 plus x power of 2 with the initial value y2 equal negative 1 is y equal plus minus x over 4 power of root 9x power of 2 negative 32. So we use for the equation yx dy over dx equal to y power of 2 plus x power of 2 And firstly, the same step, we should check whether the differential equation is homogeneous or not. So we get the differential equation is homogeneous equation with degree lambda equal to. So we use transformation y equal xv and dy over dx equal x dv over dx plus v. So we get the answer for the method of separation. We use this is integral solution, and we get the answer. Is y equal plus minus x power root of cx power of 2 minus 2, and we have initial value, so just substitute the initial value y as negative 1 and 2 as x. So we just change, so we get c equal to 9 over 16, and so the particular solution is y equal plus minus x over 4 power root of 9x power of 2 minus 32. So this is simulation of the answer of question 1b. This is the same thing with C1 from question C1. So we know that PT is sin t and QT is sin t. This is the difference from C1 and C2. The dy over dx change to di over dt. So it is the same. This is the same thing. So second step is find the integrating factor, which is substitute pt dt. So we get exponent negative cos t. Okay, next, after that we use formula y integrating factor equal integrate qx with integral dx. So we get the answer is I equal to ce power of negative cos t plus t, and we have an initial condition, which is I pi equal to exponent, so just substitute it. Pi as x and pi as t and exponent as I. So I equal to e1 exponent negative cos pi plus t plus 1.
So, question number 2 is solve y2 prime plus 6y prime plus 13y equal to exponent x. So, we obtain a equal 1, fx equal exponent x. So, we get the complementary function equal exponent 3x a cos 2x plus b sin 2x. For Wronskian, we get y1 equal exponent 3x cos 2x and y2 exponent 3x sin 2x. So we solve the Wronskian and we get the answer 2 exponent 6x. For general solution using variation of parameter, we use u equal to integral y1 fx over aw dx plus a. A is constant. So, we get the answer for u is, we get 1 over 8 exponent negative 2x cos 2x plus sin 2x plus a. This is u. For v, by using the formula y1 fx dx over aw plus b, we get the answer v equal to 1 over 8 exponent negative 2x sin 2x negative cos 2x plus b. B is constant. And lastly, we obtain the general solution y equal u y1 plus v y2. So, when we substitute the value that we have find before, so the answer is y equal to 1 over 8 exponent x plus a exponent 3x cos 2x plus b exponent 3x sin 2x. So this is the last answer, and this is the stimulation for question 2. That's all from me. Thank you.
Hello, my name is Muntasir Awad. Now I will talk about question 3a. We have two linear first order differential equation. Now we present y1 and y2 as ut and vt using yms. Y prime 1 equals xy1 plus y2. Also y prime 2 equal 5y1 plus 2y2. We will put the equation from the question, and we will present the differentiation using diff function. Then the solve the system show the solve function which return the solution as element from as structure. Next yt and ut and vt start directly by providing multiples output agreement. Uh, Lastly, the constant C1 and C2 appear because there is no condition as a specific field. Still, the value for y is not the same as the calculation. Okay, now for question 3b1 I, we will present y1 and also y2. Name the as derivatives which ut and vt using as yms. Y prime 1 equal 6y1 plus y2 plus 4 e power of 7x, and also y prime 2 equal 5y1 plus 2y2 plus 10 e power of 7x. Next, we will put the equation from the question, and we present the differentiation using the diff function. After we got the differentiation for y1 and also y2, I will solve the system through the solve function. We return the solution element of structure. The constant will be okay because there is no condition specific. Okay, for question 3bii, the particular solution of the system has the initial value, which is when x equals 0, y1 equal to 2, and y2 is equal 1. The condition in the MATLAB using CO and D 1y is equal to 0, and C on D 2 v0 is equal to 1. Then we use the solve function to find the value of the consistent. They will satisfy the condition. Okay, thank you.
Question 4a. We do further calculation. So for the question 4a, we need to do inverse Laplace transform for s over s squared plus 2s plus 4. So the denominator here, we completing the square, we will get s plus 1 square plus 3. So we just starting the inverse Laplace transform. So here, from here up here, we need to do s plus 1 and then minus 1, because we want the in the bracket here we same down here for us to easy the inverse Laplace transform. So s plus 1 we put here and then the minus 1 here, and then we do the first Laplace transform. We get from the s plus 1 over s plus 1 here, we get exponent negative t, and then here also same 1 over s plus 1 we get exponent negative t, and then for inverse Laplace s over s square plus 3 we change into square and then we put the square root, so you get cosine square root 3t minus 1 over square root 3 here, because we put square root 3 we want to same with the down here, so we change the set 3 here, so don't forget to set 3 denominator, because when we put this we will get back 1 same from this. So we inverse Laplace here, we will get the sine set 3t. So the total of it is negative 1 over set 3 exponent negative t sine set 3t. So we factor it up, the exponent negative t out here, so we get the simplified answer. After that, for question 4b, we need to do partial fraction. So to do partial fraction, we need to use the formula here, as plus b over s squared plus 1 and then plus cs plus d over cs squared plus 2s plus 4, and then you simplify it. From here we go to the right hand side, become times as plus b times s squared plus 2s plus 4 and then cs plus d times squared s squared plus 1. So we expand the bracket here, we will get like this, and then we compare the coefficient of s. So first, for the s power of 0, we get 0 equal to 4b plus d, and then we've simplified, we could become b equal to d negative d over 4, and then for the power of 1, s power of 1 equal to 4a plus 2b plus c, and then for the s square we get 0 equal to a plus b plus d, and then lastly the s cube, which is s power of 3, is 0 equal to a plus c, so we simplify it into negative a equal to c. So from we get the b equal to negative d over 4, we put it inside here first, so we get 1 over 1 equal to 4a negative d over 2 plus c. So we get the d over 2 here because we here with 2b, so 2 slash with the 4 we will remain with denominator 2, so d over 2, and then for here we change the b into the negative d over 4, and then we simplify, we will get a equal to negative 3 over 8d, and then here we convert the a into the d, so we will get 3 over 8d, c equal, and then we get from all of it, so we can get the b equal b, so b equal to negative d over 4, so we get b equal to 2 over 13, and then d equal to negative 8 over 13, and A is 3 over 13, and C is negative 3 over 13. And then after that we can do the inverse Laplace. We put the A, B, C, D into the formula. We get like this, and then we can start the inverse Laplace transform. That we put the 1 over 13 outside first, and then we split with 3s, 2, 3s, and 8 here. And then for the 3s, inverse Laplace 3s over s squared plus 1. We put the 3 outside first, and then we inverse Laplace, we get cosine t. So 3 cosine t. And then for the 2 inverse Laplace, 1 over s squared plus 1, we get sine t. So 2 sine t. And then here we get negative 3 as per negative t, because inverse Laplace from s over s plus 1. And then remaining we will get the inverse Laplace 1 over s square plus 3. So here we need to same with the formula, with s the power of 2, so we just simply put the square root of 2 here. And then we need to be same with down here with up here, so we put the set 3, and then don't forget to put the denominator set 3, so we can slash, we get the same, which is 1. And then last here the next is negative 8, because we put 8 outside and then left 1 over s plus 1, so we inverse earlier, we get exponent power of negative t. And then remaining we will get the 1 over s squared plus 3. So s squared plus 3 here we convert become power square root 3 power of 2. So we do same up here with down here. Don't forget to put the denominator set 3, because after we slash it out we get the answer back with 1. So inverse Laplace transform, here we will get cos set 3 t. And then we can, here is the last answer, which is 1 over 13 open bracket 3 cosine t plus 2 sine t minus 11 over set 3 exponent power of negative t cosine set 3t. And then for 4c, we need to use the KVL, Kirchhoff voltage law. So from voltage law, we need to get all the voltage drop from the resistor, inductor, and the capacitor equal to the voltage input, which is ET. So for resistor, we use the ITR, which is the current times with the resistance. And then for the inductor here, we use the inductance times with the derivative IT, and then plus with the voltage drop at the capacitor, we're using formula 1 over C integral I tau with limit 0 to t equal to voltage input, which is ET. So, and then we put back the information given in the question, which is the resistance is 2, so we get 2 IT plus I is 1 is the inductance value, so 1, and C is capacitance value, which is 0.25. Transform, put it here. So this is we get from the graph given. So sine t is from the 0 until pi, and then we will get 0 when t is over pi. So from this we will get the G1 is sine t, G2 0, A is pi. So the formula is here. You use the formula and then we will get the sine t minus sine t mu t minus pi. And then lastly, we can get the answer is di over dt plus 2it plus 4 integral I tau with limit 0 to t equal to sine t minus sine t mu t minus pi. So here we have shown the answer is same with the question. And then for last is 4D. So we split with left side and the right hand side. Left hand side, we need to Laplace the di over dt and Laplace 2it and then Laplace 4 integral I tau. For Laplace di over dt, we get sis minus t0 and then Laplace it, we get is, so we get 2is and then Laplace integral I tau with limit 0 to t, we will get is over s. So we factor out the is and we get s plus 2 plus 4 over s minus 1, which is we get where is I0 is 1 here. And then for the right hand side, we Laplace sine t, we get 1 over s squared plus 1. And then minus with Laplace sine t mu t minus pi. So here we Laplace and we get exponent negative pi s over s squared plus 1. So here we denominator is same, we can minus it out. So 1 minus exponent negative pi s over s squared plus 1. And then we combine back the left hand side here and the right hand side here. And then negative 1 we put at the right side become plus 1. And then s plus 2 plus 4s, we need to convert become s squared plus 2s plus 4 over s. So too easy for us calculate after this. So then we put the right to the right. So we get s over s squared plus 2s plus 4 times with the 1 minus exponent negative pi s over s squared plus 1 plus 1. After we times it up, we get like this. And then we need to split into 3, which is here, here, and here. And then we inversely transform into each of these 3. So inverse Laplace for the s over s squared plus 2s plus 4 s squared plus 1 here, we can get from the question 4b. And then at here, inverse Laplace transform s over s squared plus 2s plus 4, we get exponent negative t cosine sec 3t minus 1 over sec 3 sine pi, sine sec 3t from question 4a. And then for the inverse Laplace se exponent negative pi s over s squared plus 2s plus 4 s squared plus 1 here, we will get like this. So this is the unit step. The inverse Laplace for exponent negative pi s, we will get the mu t minus pi. So the left is inverse Laplace s over s squared plus 2s plus 4 s squared plus 1. So here inverse Laplace we also get from the question. Same with the question 4b here, and change it into here with the mu t minus pi. Don't forget to change the t with this new t minus pi. So we get 1 over 13 open bracket 3 cosine t minus pi plus 2 sine t minus pi minus 11 over sec 3 exponent power of negative open bracket t minus pi close bracket cosine sec 3 t minus pi close bracket. So we split 3 here, so we need to put back. So we can get the IT is, last answer is here, 1 over 13 open bracket 3 cosine t plus 2 sine t plus 11 over set 3 exponent negative t cosine set 3t minus open bracket 1 over 13 open bracket 3 cosine t minus pi plus 2 sine t minus pi 11 set over set 3 11 over set 3 exponent negative t negative pi cosine set 3 t minus pi. And then last is exponent negative t open bracket cosine set 3t minus 1 over set 3 sine set 3t. Okay, from the simulation we get from the MATLAB for question 4a, the calculation and the simulation answer for the 4a is same, approximate to 6 decimal place. In order to check the final answer, we assume t is 5 from the last answer from the simulation and the calculation we get. So from the calculation, after we assume t equal to 5, we will get 0.006075, and from simulation also we get 0.006075. And then for the 4b, we use the software of the Symbol Lab. We done it at the website because it make us easy to do it. Okay, from the simulation that we had done for the 4b, we get the exact answer from the calculation with approximately 2 decimal places, with assuming t equal to 5 from calculation and also the simulation. We get calculation is 0.2267 and the simulation is 0.2288 after we assume it t equal to 5 from the last answer at the simulation and also the calculation. For the question 4c, we do not need to do the simulation because we just need to show how to get the answer that shown in the question. So we have shown it, and then for the question 4D, we also do it in symbollab.com for the simulation. The data that we get from simulation is slightly different from we get on calculation. We conclude that we had some error on doing simulation because from the simulation that we have done, there is some different from our calculation, but from we get the 4A and the 4B same, so I think there is no problem for the last answer for the 4D, because 4D we depends also from the answer at the question 4A and also 4B. So maybe there is some problem to the simulation in the 4D because, as I said earlier, for it depends from the 4A and 4B. So we get the 4A 4B is exactly same, so there is no problem from our calculation.